In this video we will attempt to estimate the number of distinct paintings. Two paintings are distinct if they are meaningfully different. The cutoff for what is and isn't a meaningful difference depends on the person, but the gist of it is that we can see that they are different and pinpoint why they are different. In most cases this will be obvious, but as you'll see we're going to have to select an arbitrary cutoff point a few times. We start by trying to obtain an upper bound. We will think about a painting as being equal to a set of pixels. Now, there are infinitely many painting sizes, and so also infinitely many paintings, so we will consider only paintings of 1 million pixels. That's roughly the size of half of a computer screen. So, how many distinct paintings can a computer screen show us? To answer this question, we need to determine the number of possible color shades. Surprisingly, humans can distinguish more than 1 million different shades on average. To calculate the total number of ways to color a 1 million pixel painting, we note that the first pixel can have 1 million choices, and the second pixel also has 1 million choices, resulting in 1 million squared options for the first two pixels. We continue this process for each pixel, so we get a total of 1 million to the power 1 million possible paintings. That is 10⁶ million paintings. As a comparison, there are only 10 to the power of 79 atoms in the observable universe. I can safely say this is now by far the largest number I've ever encountered that has a conceptual meaning attached to it. Disclaimer: math graduates might not be impressed. So yay, there's quite a few paintings out there. Are we done now? No. The obtained set includes variations with noise, text, and scaled versions of previously counted paintings, which are not distinct in most cases. Furthermore, can we really say that a painting that uses the 21st shade of yellow is distinct from the one that uses the 22nd shade? Most people will agree that it's not. Lastly, two different paintings with only a few differing pixels are not distinct either, as I showed earlier. At how many differing pixels can we consider it a meaningfully different painting? It depends. The threshold for what constitutes a distinct painting varies depending on the painting's content. For instance, a painting featuring a woman with a wedding ring may be considered distinct from one without, but the removal of a few trees in the background probably won't significantly alter its perception as a unique work. Therefore we are going to have to come up with an estimate based on certain assumptions. A first idea is that we could count paintings that have more than X identical pixels in common with an already counted painting, as not distinct. It means we are excluding a huge amount of valid paintings. But we also take care of most of the not distinct paintings. I explored this idea and tried to obtain a mathematical estimate, but this turned out to be impossible. The algorithm would work as follows. Create an empty set. To this set we add paintings that are distinct from all paintings in the set. So we start with painting 1 and add it because the set is empty. Then for painting 2 we check if it's distinct from painting 1 by comparing the pixels one by one. For painting 3 we do the same, but now we compare it to painting 1 and if painting 2 is in the set, we also compare it to that. And so on. Since we have 10 to the power of 6 million sets of pixels to examine, the total number of comparisons we would have to carry out is on the order of 10 to the power of 6 million 10 to the power of 6 million. Even if you have a computer as big as the universe, this calculation would take practically forever to carry out. I tried looking into approximation methods, to no avail. I was stuck. I wanted an answer. I wanted to know if we were ever going to run out of meaningful paintings, where a person could have seen it all. After a few days, I came up with a different approach. Consider image creators, like DALL-E, Midjourney, an artist who can draw anything you ask them to. In theory, they can produce the same 10 to the power of 6 million sets of pixels by following a sequence of instructions such as color pixel 1 red, color pixel 2 blue, and so on. However, such prompts are too lengthy. We should be able to encapsulate every aspect of a painting in a relatively short prompt by describing every single aspect of that painting in the prompt. The level of detail in the image is determined by the prompt's length, and this is where the word distinct comes into play. Longer prompts result in more detailed paintings, but they also make the paintings less distinct. For instance, The prompt "Draw a woman with glasses who is sitting in a chair" has 5 ideas or aspects. There is a woman. There are glasses. The woman is wearing the glasses. There is a chair. She is sitting in the chair. But we know nothing about her hair color, her facial expression, the environment she's in, and so on. A longer prompt could be "Draw a woman with glasses sitting in a chair. Her hair color is brown. She is smiling. She is sitting in a house next to her husband." By approximately doubling the size of the prompt, we have gained a good amount of distinctness. Let's double it again. Draw a woman with glasses sitting in a chair. Her hair color is brown, she is smiling, she is sitting in a house next to her husband. Her husband is reading a book while sitting on the bed. On the bed is a cat. Outside, the sun is shining. You can see that adding more words doesn't matter so much as in the first 2 prompts, because we can mention the important aspects of the painting in a shorter prompt. Therefore, we need to strike a balance between the level of detail and the prompt's length. You can imagine that for a prompt of 1,000 words, sentences would look something like "The woman with black rectangular glasses is sitting cross-legged in the wooden chair." So we gain more detail, but it starts mattering less, in most cases. Whether the woman has rectangular glasses or not will probably not matter. At the same time, sometimes a painting is so detailed that it needs every single word, for example the Ghent altarpiece. So with this idea in mind, we must decide on an appropriate prompt length, although it is somewhat arbitrary. A length of 1,000 seems reasonable, striking a balance between being neither too low nor too high. This says that any distinct painting can be explained in 1,000 words and that anything more than that contains redundant words. If you're not convinced that we need 1,000 words for our prompt, let's try it out. Start counting on a painting. Or alternatively, give DALL-E a 100-word prompt and see how different the results can be even when they adhere to the prompt perfectly. Now, I'll estimate the total number of words at 100.000, based on Googling a bit. This means we can get 100,000 to the power of 1,000 prompts equals 10 to the power of 5,000. Since every prompt is supposed to give us a different distinct painting, we get 10 to the power of 5,000 as a new estimate for the total number of distinct paintings. Hooray! We reduced it from 10 to the power of 6 million to 10 to the power of 5,000. Remarkable progress. Now there might be very specific paintings that require more than 1,000 words. For example, a portrait of a famous person, such as Leonardo DiCaprio or Albert Einstein, requires an accurate description to capture the unique features of their faces. In fact, almost every painting of a human is distinct from that of any other human because 2 humans almost never look the same. So to describe a face accurately, requires a lot of words, because you need to specify every detail of their face to succeed. Humans evolved to recognize tiny variations in faces. This is why looking at 2 cows, you don't consider them all that different relative to the case where we compare 2 humans. To describe a face you need to specify the distance from eye to eye, from nose to eye, from mouth to forehead and so on. Luckily we get many distances for free. If we know the distance from A to B and B to C, we know A to C. So these paintings might need more than 1,000 words. Perhaps 2,000, let's say. That's 4 pages of typed words for reference. Does this mean we must alter our assumption of a 1,000-word prompt length? No. It's true that to describe each face might require more than 1,000 words, but the word pool becomes much smaller as well. We assumed 100,000 different words for our prompts, but this would be a strong overestimation when we consider only facial paintings, since faces can be described with probably a few hundred words or less. If we count the digits, a few units of distance like centimeters, and a few dozen nouns related to the face like nose, mouth, wrinkle, we can already describe most faces. So there's no issue here. Let's continue. Is 10 to the power of 5,000 the final result? No. We can further refine our calculation. Why? Because this number is based on the assumption that we are working with prompts consisting of exactly 1,000 words. However, consider the following prompts: a woman is sitting in a chair. To the right of the chair, a cat is sleeping, and a cat is sleeping. To the left of the cat, a woman is sitting in a chair. These prompts convey the same information. This means we need to divide by the number of permutations. To solve this we need the average length of a sentence. Okay, technically average is not exact but we are approximating anyway, so. First let's split every sentence into its smallest subunits so we aren't dealing with sentences like the woman is sleeping on the bed while the cat is next to the chair and the sun is shining outside, which makes the average sentence length impossible to estimate. Here is one of our earlier prompts again. Draw a woman with glasses sitting in a chair. Her hair color is brown. She is smiling. She is in a house next to her husband. Her husband is reading a book while sitting on the bed. On the bed is a cat. Outside, the sun is shining. When split into subunits, this becomes: draw a smiling woman. The woman has glasses. She is sitting in a chair. Her hair color is brown. She is in a house. She is next to her husband. Her husband is reading a book. The husband is sitting on the bed. On the bed is a cat. Outside, the sun is shining. We have gained words, so prompts will become longer. But only by 10% or so. If we want we can change the prompt length from 1000 to 1100, but 1000 was an arbitrary round number anyway, so never mind. Looking at the prompt, the average sentence seems to have a length of about 5. After inspecting a few more examples, 6 felt like a more representative number though, so it takes on average 6 words to express one idea based on my own relatively small sample size. This means our prompt has 1006 equals 167 sentences or subunits. Therefore, 10 to the power of 5000 divided by 167 factorial equals 10 to the power of 4700. We can continue. Many of the included prompts are meaningless sentences. The number 10 to the power of 4700 includes prompts such as hey table I me hello. Hospital done have been yes. In other words, most prompts are nonsensical. We need to determine the number of valid sentences of length 6, and which of those are valid descriptions for a painting. I sought assistance from ChatGPT to help with this analysis. Nouns are the most abundant, so let's say 2 words out of 6 are nouns, and 1 is verb, then 1 article, a/the. This is an overestimation. Most have 2 articles, an adjective and a preposition, on, in, behind. Other sentences are possible, but at most it would increase our results by a factor of 3 give or take. From Chat we can find the number of nouns, verbs, adjectives and so on. We get 100,000 times 100,000 times 12,000 times 4,000 times 2 times 100. Also assume every noun, adjective and preposition has one synonym or something that very closely resembles the original word, while every verb has 10. 50,000 times 50,000 times 1,200 times 2,000 times 2 times 50 equals 6 times 10 to the power of 17. Don't forget, not all nouns or verbs are useful, for example calorie/invent. Also many nouns can lead to another noun. For example, saying draw an animal with 4 legs, a tail, pointy ears, whiskers, etc., will lead to a cat painting. Therefore I estimate that 1 in 5 nouns is valid, and the same for verbs. For adjectives I estimate 1 in 10. This equals 10,000 times 10,000 1,200 fifths 200 times 2 times 50 equals 4.8 times 10 to the power of 14. Now since we have 167 subunits, we get 4.8 times 10 to the power of 14 to the power of 167 divided by 167 factorial equals 10 to the power of 2,200 possible prompts/paintings. Even now, we overestimate, because a sentence such as on the bed is a cat can be restructured into a cat is on the bed or bed, the cat is on. So let's say every idea of length 6 can be expressed in 10 different ways by reordering of words. We get 4.8 times 10 to the power of 14 divided by 10, to the power of 167 divided by 167 factorial equals 10 to the power of 2000. That's as good as it gets for me. I'm sure you can do even better and carefully analyze the sentences better. There are still easy ways to improve the result. For example, if we adhere to all the above restrictions, the following would be a proper prompt: the woman sits on the bed. 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 And so on. In other words, you want all subunits to be different. Ultimately, this one doesn't really alter the result too much, it only gives something around 10 to the power of 50 overcounted prompts, which is nothing compared to 10 to the power of 2000. To recap, here are the approximations that we made to get to 10 to the power of 2000: 1. Prompt length 1000. 2. Split sentences into units of length 6. 3. Estimated the number of verbs, nouns, and so on. 4. Assumed every sentence of length 6 consists of 2 nouns, 1 verb, 1 adjective, 1 preposition, and 1 article. 5. Estimated the number of synonyms for each type of word. 6. Estimated the number of words that are valid for painting descriptions. 7. Estimated number of ways a set of words can be ordered to form a sentence with the same meaning. If you're shocked that there are so many paintings, note that almost everything you ever saw is part of the result we calculated. On a daily basis you see literally hundreds of thousands of paintings, because everything your eyes see is a painting. A hyper-realistic painting that someone could draw. I could go in my street right now and give you 1000 different paintings of that street. They're boring, but distinct. I didn't calculate the number of interesting paintings, remember? And I could do it in 100 art styles. It includes just about every experience a human can have, every face from 100 different angles, every landscape, every weird unthinkable thing, everything. Well, not everything, remember 10 to the power of 6 million.